All right, picture this. It's May 1969. NASA is standing right on the absolute edge of its greatest achievement in history. I mean, they've already tested the massive Saturn V rocket, they've flown astronauts all the way around the moon, and they've proven the lunar module actually works in the deep vacuum of space. There is literally just one towering hurdle left before they can actually put boots on the lunar surface. Which brings us to a massive, mind-bending question. It's really the ultimate engineering and human puzzle. How do you practice for a moon landing? Seriously, how can NASA possibly test every single highly complex procedure in the unforgiving vacuum of space under actual real-world conditions without, actually touching down? Well, the answer is by doing everything except landing. This wasn't just a quick simulator run. This was Apollo 10. And as we'll see in this explainer, it was an incredibly demanding, dangerous flight that absolutely had to succeed, because if it failed, the whole dream of landing on the moon before the decade was out would just vanish. Let's dive into our first section, the crew and the craft. To pull a mission like this off, you obviously need the right people. You've got Commander Thomas Stafford, Command Module Pilot John Young, and Lunar Module Pilot Eugene Cernan. These are three incredibly experienced astronauts, perfectly suited for what would be one of history's absolute most complex and ambitious flights. Now, I love this detail. The command module was affectionately named Charlie Brown, and the lunar module was Snoopy. It totally reflected the crew's lighthearted spirit, but make no mistake, this mission was deadly serious. The exact data gathered by Snoopy and Charlie Brown would literally dictate if a real landing could be attempted just a few months later. All right, moving right along to Section 2, descending to the moon. So let's trace their path. On May 18, 1969, Apollo 10 lifts off flawlessly on a massive Saturn V rocket. They hit Earth orbit for some initial systems checks, fire up that third stage engine, and shoot straight out into deep space. Days later, they successfully arrive. And just like that, for only the second time in human history, we have humans circling the moon. Once they're in orbit, the real rehearsal gets underway. Step 1, Stafford and Cernan enter Snoopy. Step 2, they physically separate from Charlie Brown, leaving John Young completely alone in lunar orbit. And Step 3, they fire the descent engine, dropping aggressively toward that uncharted lunar surface. 15 kilometers. Let that sink in. 15 kilometers, or just under 10 miles, that is how incredibly close they hovered right above the moon. From this unbelievably low altitude, Stafford and Cernan stared right down at the exact intended landing site for Apollo 11. They were visually verifying that the terrain was actually suitable and safe for the next crew. But then we hit our next section, the terrifying tumble. It happens in an absolute flash. While they're preparing to separate the descent stage from the ascent stage, which is this highly delicate critical maneuver, an incorrect switch configuration gets triggered. This single error starts feeding rapidly changing guidance inputs straight into the computer. Suddenly, Snoopy begins to unpredictably spin and violently tumble in the vacuum of space, literally just miles above the lunar surface. It is a terrifying, breathless moment where the entire mission, and frankly the astronauts' lives, are just hanging by a thread. But as NASA would later officially note, their calm handling of the situation prevented a potentially serious accident and demonstrated the importance of training and crew coordination. I mean, Stafford and Cernan just didn't panic. With lightning-fast reflexes honed by thousands of hours of training, they fought that spin and manually wrestled back control of the spacecraft. So what happened next? Step 1, they regain stability. Step 2, they successfully test the ascent engine, which boosts them back up. And finally, Step 3, they rendezvous and safely dock with Charlie Brown. Honestly, this brilliant recovery proved the absolute most critical architecture of the whole Apollo program, their ability to launch up from the moon and safely reconnect in orbit. Which brings us to our final section, the legacy of Apollo 10. When you look back, the technical wins from this mission were just massive. They operated the lunar module in actual lunar orbit. They descended incredibly close to the surface. They survived and handled a real-time, completely unexpected emergency. But most importantly, they removed the remaining uncertainty. Engineers finally had undeniable proof that the hardware was truly ready to go. And here is the crazy part. Just 2 months later, 2 months, Neil Armstrong, Buzz Aldrin, and Michael Collins would fly Apollo 11. When the Eagle finally descended to the surface, they were following the exact procedures that Apollo 10 had just tested, validated, and proven under intense fire. You know, Apollo 10 is so often overshadowed simply because it didn't actually land. But the true story of this mission is really one of precision, courage, and ultimate restraint. Because great achievements depend on disciplined execution. Think about it. Stafford, Cernan, and Young traveled all the way to the moon, rehearsed the whole thing perfectly, and then had the extraordinary discipline to turn around and return home without taking that final step. Which leaves us to ponder something pretty profound to wrap up this explainer. Is stopping just short of the finish line sometimes the bravest step of all? Because by exercising that incredible restraint, Apollo 10 literally made history's greatest leap possible.